Hey guys, welcome back to Mr. MathWell's YouTube channel where we do math. Alright, so today we're going to talk about LHopitals Rule. So, LHopitals Rule can help us calculate a limit that may otherwise be hard or impossible to determine. So, this rule says that the limit when we divide one function by another function is the same after we take the derivative of each function. So that looks like this. The limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. Alright, so that might be a little bit confusing right now, but I'll explain. So let's consider the function, this function. Okay, so the limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4. Okay, so if we plug in 2 for our x, we get 2 squared plus 2 minus 6 over 2 squared minus 4. Now, if you can't figure that out, I don't know why you're in this class, but equals 0 over 0, which is, we can't determine that limit. But if we try and use LHopitals Rule and take the derivative of the top and the bottom, we get, let's do it over here. What in the world? Okay, so we get, oh my, the okay. So, if we take the derivative of the limit of as x approaches 2 of x squared minus x, no, plus x minus 6 all over x squared minus 4, we already figured that that was 0, 0, but if we take the derivative, we get 2x plus 1 over 2x. And then we can go and determine what that is. So if we plug in 2 to our function, we have 2 times 2 plus 1 over 2 times 2, which gives us 5 over 4. And that, ladies and gentlemen, is your limit. Yay! We did it. Okay, I hope this is starting to make sense, but let's try a new one. Okay, so, okay. So, if we plug in our thing, we get this. And now that cannot be determined. So, we need to do LHopitals Rule again. So, LHopitals Rule again is taking the derivative of the top over the derivative of the bottom. So, we have the limit as x approaches infinity of the derivative of e to the x is just e to the x over 2x. But we run into a problem. That equals this again, which cannot be determined. So, we need to do LHopitals Rule one more time. I think in your textbook this is called taking it to the higher power. But, so, we need to go. Limit as, oh, okay, that's fine. Limit as x approaches infinity. Derivative of e to the x is e to the x. Derivative of 2x is 2. So then we get infinity over 2, oh my, which is equal to infinity. And that is our limit. We have done it again. Go us. Okay, so this one is going to also equal 0 over 0, so we're going to have to use LHopitals Rule again. So if we evaluate this, we take the derivative of the top over derivative of the bottom, so we have the limit as x approaches 0. The derivative of sine is, we go, derivative of sine is cos 5x times the derivative of the inside, which is just 5 over 1. So then we get the limit as x approaches, oh my goodness, as x approaches 0 of 5 times cos 5x over 1. And if we plug 0 in, it simplifies to 5 times 1 over 1, which is equal to 5, which is our limit. Oh my. Okay, let's do one last question. This one's a little bit more tricky, but we just need to keep in mind that root 2 plus x can also be written like x, 2 plus x to the 1/2. That'll help us when we are taking the derivative. Okay, so this is going to equal the limit as x approaches 2 of, and if we take the derivative of 2 plus x to the 1/2, we get 1/2, 2 plus x to the negative 1/2 minus 2 all over 1. This, oh no, is further going to take us to this. We get the limit as x approaches 2, and then we have 1 on top. Oh, this negative 2 is gone because constant derivative is just 0. Okay, then we have 1 over 2. That 2 plus x comes down in a root sign at the bottom. X times 1. This will equal, if we plug in our x, we get 1 over 2 times root 2 plus 2 times 1. And this will, okay, this will bring us to equal 1 over 2, the root, square root, oh, things are disappearing, 4 is just 2 times 1, and our limit is going to be 1 over 4. Oh, I don't know if you guys can see that. 1 over 4 is our limit. Alright, that brings us to the end of our lesson on LHopitals Rule. So make sure you give this video a big thumbs up and subscribe down below. And remember, if you're gonna do math, do math
well. Actually, the mic's still on too, so do you want to say goodbye? One last goodbye.
Bye.
Bye from the tiger.